So I wanted to start off really highlighting what's wrong and what we do different with front end, which I would characterize now as a post-JavaScript development framework. Front end does not rely on JavaScript to move pixels around and render things. It is not held up by the CPU, by the compute, by the type of things that ding you on page speed. What does that look like? What does that feel like? And how does that come through with site metrics? I thought a really cool example to start with would be Costco.com versus Costco Connection. Costco.com is not us. Costco Connection is us entirely from header to footer. So it makes it a really good sort of comparison. You got roughly the same number of images, same number of pixels, relatively similar amount of content. Let's look at a couple of things that kind of jump out on Costco.com. And I'll go through, I think, in increasing order of nerdiness, the different performance testing tools and analysis tools that we'll look into to kind of highlight the differences between these two sites. If we talk about the core web vitals, we talk about the one additional metric that shows up in page speed. So one is largest contentful paint. Contentful is a cool word. Google made it up. I kind of like it. But this is the largest set of pixels on the page. So there's this pixels above the fold. How long did it take you to get to the point where you rendered that? Cumulative layout shift. Costco.com actually gets dinged. You can see it. I mean, it jumps off the screen at you. You see this area here sort of snap in after the fact. That's a classic blunder that you see on a lot of sites that are using JavaScript. That's what we define as a layout shift. And it's that jarring user experience of like, I was starting to look at this page and interact with it, and the whole thing shifted out from under me. And then the metric that is incredibly infuriating and hard to debug if you have a JavaScript-heavy site is this total blocking time metric down here. So this is, as we're starting to get nerdier and nerdier, that is a metric that more often than not, if you see a really high number like that, and spoiler alert, in these page speed things, red is bad. If you see a really ugly red high number like that, that means the browser's spending a bunch of time either parsing JavaScript, evaluating JavaScript, or using JavaScript to re-render parts of the page to respond to user events like clicks and mouse over, things like that. You can see the latest core web vital, and this was, I think, one of the real inspirations for us to move in the direction of post-JavaScript. Interaction in XPaint is Google laser focusing on single page apps, on React, on Angular, to specifically penalize them, because this is from the point that somebody mouses over something, somebody clicks on something, how long did it take for the browser to reflect that, to show you the next scene, to show you the next transition. It's a metric that is designed to say, hey, if you're doing a thing that's reactive, it's responding to that event, and then running 10,000 lines of code to show you the next scene, we're going to penalize you and you're going to fail core web vitals. They introduced this one in the middle of last year, and everyone lost their minds because they were like, oh, my site performs great. And then all of a sudden it didn't, because that one, especially if it's a heavy JavaScript site, incredibly hard to get a good score on that. So we saw that coming. That was a major reason why we architected things differently with front end. So this is the high level score. This is the core web vitals assessment, always looking at mobile. Mobile is, of course, the hardest to try and achieve a good score on, particularly with this area down here. This is Google running an instant test to assess in detail what they think the performance of this page will be on mobile. They assess this simulating a super old Motorola device. This is how hard they're making it. But that red total blocking time, that's what drags them down so much. If you scroll down, again, we're getting nerdier and nerdier here. You look at what is dinging them on the performance of all this JavaScript execution. In total, they're spending 6.5 seconds just executing JavaScript. And you see how that flows through directly to the largest contentful paint. When did we render that to the screen? Because there's now 8.5 seconds that they're assessing. You're waiting for all that JavaScript to run before we can load that image, before we can get that up on the screen. So really the combination of those things at a high level, atrocious largest contentful paint, massive wedge of total blocking time, those are what drags them down from a reasonable score to 5, which is bananas. So jumping forward to what Costco Connection looks like, and this is sitting on top of Fastr front end, exclusively front end, header to footer here. Again, mobile performance score, it's an 89. Same number of pixels, same level of complexity in the page, just dramatically different total blocking time. Green, again, is good. 160 milliseconds versus that 2.5 seconds. A largest contentful paint that's 13 seconds quicker, or whatever it is in this assessment. And most of the things that you would see here, I think if you were to go through sort of block by block and say like this naughty list that folks get yelled at for the different crimes against performance, There's a whole bunch on Costco.com. There are a bunch that don't show up for us at all because our images are optimized. We're not running a bunch of JavaScript that's in the way of rendering. It's just a tighter, more concise bundle of content on the page. And if we go to, oh, and also a really cool thing. One thing I will highlight, and this is really for folks who've also pulled their hair out trying to optimize performance of sites. A lot of times you'll observe this situation where you're testing something in your browser, you're running Lighthouse and you're getting like an 89 or a 70 or a 60, and then you go to run a thing in page speed and you get like a 30 or a 40, and you're like, it's the same content. What is the difference? That is because of that difference in how long it takes to execute all that JavaScript on Google servers versus ours. Really nice thing about when you run local Lighthouse for faster front-end experiences, you're going to see the same score that you see there versus what you see on Google's, because there's just not that variability of like, oh, sometimes it takes a lot of time to process JavaScript. Well, we ain't JavaScript, so we're fast no matter where you run us. Makes it a lot easier to go live with confidence. And now we come to the nerdiest that I could possibly get. Let's get down into debugging the actual CPU of a browser and what it's doing. We'll just stick to a pie chart instead of all of this stuff down here. This is representing all of the time that the browser's CPU is busy. And what this is telling you between these two blocks you see here, again, this is Costco.com. This is that Next.js heavy framework site. 75% of the browser's time is just spent in JavaScript land trying to get ready to render things, or even just processing all of the stupid JavaScript they have to download just to get out of bed and get their pants on. Like that is what it's going to take to get anything at all rendered. And that is not what you see with front end. Again, with front end, what you're doing is I'm spending close to half your time, 40% of your time. This is where you're actually working on rendering the layout and drawing everything to the screen. You're looking at the time it takes to render the actual HTML, to parse the network images. And this is focused on the stuff that matters. Get those pixels in front of users. So I know that takes us real deep into what the performance differences are, what the characteristics are, why we would refer to ourselves as a post JavaScript framework. And let's talk about what it actually looks like under the hood.